Hey guys, and welcome to this video as I explain your first challenge as we explore this concept of slope a little further and actually discover some concepts that lay the foundation for our future discussion of calculus. So here we go. So far, we have discussed a whole bunch of graphs of lines, like y equals 5 plus 2x. And we've talked about something called slope. In this case, this line, this graph, has a slope of 2. Why? Because every single time x goes up by 1 unit, y increases by 2 units. If x goes up by 1 unit, y increases by 2 units. And this is a way we've talked about slope a little bit, is slope represents, it's a rate of change. It says how quickly is our dependent variable changing. Is it changing a lot? Is it changing a little? Is it increasing? Is it decreasing? So that's what slope is all about. Here's another linear equation we've graphed, something like y equals 4 minus 1/5 x. Right? And here we have a slope of negative 1/5. But what does this mean? It means that what's the rate of change of y, of our dependent variable? Well, it's saying it's not changing very quickly and it's also decreasing. So as x increases, y gets smaller very slowly. In fact, it takes a full 5 units increase in x for y to decrease by just 1. So we have the point 0, 4. If x goes all the way up to 5, y goes down just 1 unit. And one thing I want to note is that for a line, the slope, the rate of change, is always constant. The slope is always negative 1/5 in this one. Or the slope is always positive 2 for this one. But what happens when we talk about the slope for a graph that's not a line? So something like y equals x squared. How can we talk about the slope of this graph? Because the slope is constantly changing. Sometimes y is decreasing, sometimes y is increasing. Sometimes it's increasing and decreasing very slowly. Sometimes it's increasing and decreasing very quickly. So we can't talk about the slope of a curve because the slope is constantly changing. The rate of change of y is constantly changing. So how do we have that conversation? Well, we need to introduce something called a tangent line. And a tangent line is a line that for a local area, a local interval, right around a point, this line in orange hits this line in blue exactly once and never again. Right at that point. Right at that point, 1.42, 2.0164. That is the only point when that orange line intersects this blue line. This blue curve, And what we'd say is that the slope of this line in orange, and this orange line has a constant slope, that slope is, what we would say is, that's the slope of this blue curve for that specific x value at 1.42, right? And so note that the slope of this tangent line is constantly changing. And so like right here at -1, at the point -1, 1, the slope of this orange line, I don't know what it is, it's negative something, we'd say the slope of that orange line is equal to the slope of y equals x squared at the x value, -1. And so your challenge is to figure out the slope of this blue curve using tangent lines when x equals -3, -2, -1, 0, 1, 2, and 3. And see if you can find a pattern between the x value and the slope of this graph in blue. And please make sure to include lots and lots of pictures of the tangent lines that you found, how you figured out their slopes, recording all of those slopes at the appropriate x values, and kind of showing exactly how you found the pattern between a particular x value and what the slope of y equals x squared was there. So good luck.